All right. So what I pulled, I was looking for some EOC questions for us to really like practice and throw back. There's not a lot of EOC release stuff that we've done yet, except for statistics. We've done a lot of work, basically working up to skills we're going to need for things in the future. So this one is going to be a throwback. It's not linear. And then our other three that are from some of the review packets are linear. And then after that, I just reworded a couple more that are EOC release questions. Again, that are linear. So really looking into the lesson we're doing right now. Interpretation is your biggest thing of linear right now. And then obviously being able to write them. But, so an administrator at a local hospital recorded the weights of newborn babies. For year 2016, the mean weight of babies, so mean, what is another word for mean? What is mean? Or what is the mean? They're not mean babies, but mean is the average, right? So if you added all their weights up, yep, and then divided by the number of babies weights that we had, like how many babies they weighed, that would be your mean. Mean is average. Simple question, but these are the kind of things we want to make sure we are like confident, because vocabulary is what stumps us a lot. So for the first one, in 2016, it's 7.3 pounds and a standard deviation of 0.8 pounds. Now, talking to some of my Math 3 kids, and it might be just the gap in time because you do not work on this necessarily in Math 2, but that means, so the mean is your middle. Your mean is your average. Standard deviation is going to be a count to right to left of the averages, like the data around it. So that means 0.8 this way and 0.8 this way would be one standard deviation within the mean. So that means this one, the one forward, like larger, would be 7.3 plus 8 would be 8.1. That would be one standard deviation away. I could subtract 0.8. I desperately need a calculator, or I'm going to do this math wrong in my head for sure. So 7.3 minus 0.8. Is going to be 6.5. So that's one standard deviation. Yeah, thanks, Eli. And then you could do two standard deviations. So we could go one more time, and that would be 8.9. If we subtracted 0.8 from 6.5, we'd have 5.7. So that's two standard deviations. For 2017, the mean weight is 7.5. And the standard deviation is 0.61. So if I went, so we're starting here, we're going to go this way, 0.61. So 7.5 plus 0.61 is going to be 8.11. Go one more standard deviation. This is our mean. That's one standard deviation. Then add 0.61 again, 8.72. Then we go the other way, 7.5 minus 0.61 is 6.89. Go one more, and 6.28. And this conversation is like, so the data for the first one within two standard deviations is from 5.7 to 8.9. For the second one is from 6.28 to 8.72. This is a smaller spread, so that means more data is falling within that amount of numbers. More weights are between those, whereas this starts to get kind of spread out. After three standard deviations, you're no longer having a conversation about what's happening out there, because that's far. If you've seen, there's a bell curve that has those standard deviations marked off for you as well. That's something within reason on what you're looking for as far as like future data and things you're going to actually pay attention to. Not hugely pertinent for Math 1 level, but it gives it some like meat to it. But the standard deviations, again, is basically showing where the spread is in most of your data, how far out they are in variance. So kind of like range, but not. It's a little more telling, a little more average-ish. So the weights of 2016 are more spread out around the mean than those of 2017. So this is 17, so it's 6.28. It is indeed more spread out, because 8.9 to 5.7 is a larger spread. So that one's looking good, but let's make sure. The weights of 2016 are less spread out. That's not the case, because this is a lower number than that one. So definitely not B. The weights of 2000 are skewed left, while the weights of 2017, and I just left out the 16 part, sorry. The weights of 2016 are skewed left, while the weights of 2017 are skewed right. You don't have enough information to decide that. The skew left and the skew right is typically dealing with outliers. And just as a review, so this is skewed right. This is skewed left. And skew is talking about that outlier. Like, so most of your data is going to fall in your big hump, and then something happened. So if it's skewed to the left, and it was test scores, that means somebody scored, like the sleepy kid in the back scored really low. If it's skewed to the right, that means the teacher may or may not have done a great job at doing, instructing everyone, but somebody did really great because it's to the right. And if skewed left and skewed right is something that's hard for you to remember, I don't know why this makes sense to me, follow the tail. And I see this as a big bushy, like, raccoon tail. Or if you think about even peacock tails are way more cool than the actual peacock themselves. And as you've picked up, I come up with really weird ways to remember things. But follow the tail for skew. If it's skewed right or skewed left, it's whichever direction the tail is in. So we don't have enough information because we don't know if there's an outlier. And there is no difference in the spread of weights for 2016 and 2017. That is not the case because 2 standard deviations here is only to 6.28. So our answer is definitely A. Not a super hard question, but I wasn't sure if we fully understood like what standard deviation meant as far as to it being more spread out or less spread out. So that standard deviation lives on either side of your mean, 1 on either side, 2 on either side, 3 on either side, kind of that idea. So the answer for that one would be A. So moving right along to linear questions. So line M passes through the point 610 and 4, 6. Which equation represents a line perpendicular? Okay, just as a reminder, what does the word perpendicular mean? Not necessarily, yeah. What are you going to tell? You can tell me whatever you want about perpendicular. At this point, when you see the word perpendicular, all right, so we think about opposite. What else do you think about when you see the word perpendicular? Perpendicular. Opposite and flip. Good. So that's our slope, right? Our slope has to be opposite and flipped, or reciprocal if we want to use the big math word. So opposite, flip. Remember, perpendicular means they intersect at 90 degrees. So they intersect at 90 degrees. And they don't bisect, they intersect. That just means they cross, and they're going to make that little box if they cross each other. So opposite, flip for slope. So we're trying to decide which one of these is perpendicular to this. Now, at that rate, slope-intercept would be what most students would think at this moment. All you actually have to compare, though, is your slope. So we need to know the slope of the line they've given and then find its opposite and flip in the answer choices. So I have 6, 10, 4, 6. I like to stack them because that means I keep my x's with my x's. So my first coordinate, second coordinate, then you subtract. So stack, subtract, and then who goes on top, y or x? You tell me. Yes, Y on top because he's tall and skinny. Remember we told you the trampoline story? Short and squatty's on the bottom. Arms are up in the air. You're jumping on the trampoline. So Y's on top. So we're going to take that 4. 10 minus 6 is 4. 6 minus 4 is 2. They're all positive, so we're good. So 4 over 2. But we want to always reduce because we're in high school. So that's going to be 2 over 1, otherwise known as 2. So the slope of the coordinates given is going to be 2. We need the opposite reciprocal to answer this question. The word perpendicular is hugely important because they gave you all the okie doke answers on this one, the ones that are coming for you. So that same slope of the positive 2 would be what kind of line? Remember? Not perpendicular, but starts with a P. Yes, good. Parallel. So same slope would be parallel. So D's out. We can't use D because that line's going to never touch the line that passed through these 2 points. All right. So we have, what's the opposite of a positive 2? negative 2, right? So we do it step by step. And then we got to flip it, which just means it's going to turn into what? Close. Yep, negative 1/2. So remember, it's over positive 1, and then we flip the fraction. So negative 1/2. So this is the opposite part. This is the flip part. So you got an opposite and flip. So the problem with A is this is just opposite. So super close, but we stop too soon. Problem with C is this is the flip, but no opposite. So again, I guess stop too soon. You could flip it first. And so B is our answer because of that negative 1/2 slope. The y-intercepts do not matter at all, not even a little bit. So that negative 2, the positive 9, positive 11, positive 14 mean absolute squat to this question. All right, curve it. Oh, wow. Put 2 words together. Kelly surveys several students asking for the number of hours they spend daily on social media and for their grade point average. Wow. She models the data with a linear best fit function. Which correlation coefficient would indicate the strongest relationship between the variables? So strongest relationship. Correlation coefficient. That's what you've been doing the last couple of days. I'm going to give you a second and let's see if you have it. Take a minute. So I got 0.4, 0.2, negative 0.5, and negative 0.9. Okay. Which answer do you think is the strongest relationship? We are not discussing positive and negative. We're just discussing strong. So it's a tight group of coordinates. Lots of little dots. All right. Anyone else? Okay. So our guess was 0.4. Not a terrible guess, but I'm going to throw this out there that it might be your like, I got you answer. Okay. And the reason being is because strong, you're thinking positive and negative. So positive and negative, positive versus negative, are a separate question versus strong versus weak. A strong negative is still strong. All that's saying, so positive and negative decides if the data is going this way versus this way. And that would be like, so the more hours, if let's just say the x-axis was the hours you spent on social media and your test scores are running, or your class scores are running up your y-axis. So the more you spend on social media, the lower your scores are going. That's just a negative correlation. The more time you spend on social media and the higher your class score gets, that would be that positive, because the more time I spend as I travel on the x-axis, as it increases, y would increase, would be positive. So positive versus negative has nothing to do with strong versus weak. Strong versus weak has to do with how close the data is together. Like, is it closely, or is it just like whoop, like sort of, maybe, kind of. And the reason the strong and weak is something to be discussed is because, do you think every single person who spends 4 hours a day on social media has the same class average? No, right? Because some people can do multitask. Some people are just really good at school. Some people finish their work early and they spend their time on social media. Some people spend 4 hours a day on social media and don't do schoolwork, so their grade is completely blown out of the water. So it's not going to be super linear necessarily, or even if it was quadratic or exponential or any of those other type functions, which we'll get into later, it's not going to be a straight line. Like, it's not a hard line. If you spend 4 hours, you're going to have a 92. If you spend 5 hours, you're going to have an 82. If you spend 6 hours, you're going to have a 70. We can't say that. And it'd be true for sure. We can make a general rule. That's where you get your line of best fit from. So the strong and weak is just, does it look like there is a pretty good correlation? If it's a weak correlation, they usually say there's not a lot of correlation, or no correlation is no correlation as well. All of those things are very important when they use this data. So I like to think about the strength of the relationship all relative to the number 1. So it can be above 1 or less than 1 as far as positive. I'm sorry, 0 is in the middle. Positive 1, negative 1. How close it's getting to each. It's all a negative 1 to positive 1. So again, maybe not to you guys. I've said it a lot lately, though. So everything to me is like money or food. If I can make it make sense to money or food, I'm great. How close am I to a dollar? Disregard the positive negative. So the fact that this is positive and this is positive, that's fine. That just means that we're referring to a positive correlation. So that data is going up. These two are negative. All that says is we have a negative correlation and it's going down. Strong and weak is how close, so disregard the minus, are each of these numbers to either a negative dollar or a positive dollar. So in that case, 90 cents, though it is negative, is closer to a dollar than 0.5, so 50 cents versus 0.2 versus 0.4. So 40, 20, 50, and 90 cents. 90 cents is closer to a dollar. So strong is close to a dollar, whether it be a positive dollar or a negative dollar. The positive and negative symbols in the front refer to the first in this list, not what we're asking in the questions. All right. Hopefully I didn't overtalk that to death. This guy. So fun with data that is not perfectly linear. So it did go 2, 4, 6, 8. So this looks good every 2, but it's not a consistent change all the way down. Like we can't do our slope on the outside of our table. Like we can find our rise is 2 over here, but our run is inconsistent because here it's like 325 and then a lot more than that. Not 325, then 400. Then it changes. So it's not consistent all the way through. So that means the best we can do is a line of best fit. And hopefully we've done that in Desmos and you've done it in your calculator. I find it easier in a calculator than in Desmos. But what you will do to do this is go to your stat edit. And you're going to put in 0, enter 2, 4, 6, 8. So you put your X values in the first column. Your Y values in the second column. The more you can practice this, the better, because your problem won't be, you'll know that you can do it in your calculator, you won't remember which buttons to push. So the first button is stat, and then we're going to hit enter, which is going to be edit. So X and L1, Y and L2. And then we're going to hit stat, right over to calc. Linear regression is number 4. So we're going to hit stat, right over to calc. Linreg, which is number 4, is the next button you're going to push. And then depending on which calculator you have, how many times you have to hit enter to get all the way down to calculate. And if you do not cut on your, oh man, I can't think of the word right now. It just left me. Like it was in my brain, on my tongue, and gone. This will answer our question for this question, but for your correlation, so to decide if this is a good line or a bad line, you need to have R's. And I will come back to that because if I start talking about it right now, I will lose it. But you do need to have that on if you want to use, if you have to discuss correlation. But in this case, it has A is equal to 17.6.25. A is our slope, and then 10,580 is our y-intercept, and we have our line of best fit. So it says approximate, so don't panic if it doesn't match perfectly, but we want 176-ish in the front, so it has to be B. If you have your calculator buttons memorized, that is all you have to do for this question. There is no magic in this question. No real interpretation in this question. This is an EOC style release question. This should be in the bag if you remember how to use your calculator. So stat edit, enter your data into your L1, L2, stat calc, linear regression. The sooner you can learn it, the better, because we are going to use exponential and quadratic regressions as well. And if you go to stat calc, you'll see quadratic regression is number 5. We don't use cubic, but in the event you're in a higher level math and you do, it's 6, and your exponential regression is 0. We will get to that. So you will use all of them. So this is a good thing to, the sooner you can figure it out, the better. In Desmos, you have to put it in appropriately, like the coding, to get it to give it to you. If you learned it perfect. You can do it perfectly. It can graph it for you. You can use the graph. You can click on the graph. You can get more tables. You can do a lot of things in Desmos as well. I find just getting the regression is a hair easier in a calculator for me. But it could be also that I've spent a lot more time on TI-84s than I did on Desmos. So whichever one works, both are available. Just make sure you can do one of them. Now, a conversation that I've heard students have a problem with. This says in our table of data, the tuition in 2010 is $10,060 or $10,600. With our rule, that's the word that people are going to use that you don't like, students don't like, instead of the word equation. This is the rule or line of best fit that is set for the data that was given. So this increase in tuition, if we were to make it linear, so you could speak to like average increase in tuition, what is it going to cost in 10 years after 2010? What is it going to cost in 2025? This rule is made so you can make those assumptions in the future. So this rule says that every year it's going to increase $176.25. So increase, because it's positive every year. Even though our table was going by twos, we just got the line of best fit from that data that is going to count by ones, because then in 1 year we can put it in X, 2 years, 3, 4, and go all the way up. So if I wanted to find out what the tuition was in 2025, that would be 15 years, so we would put a 15 in the place of X in the rule, because we don't have the data for 2025 in the table, and that's why the rule exists. So the rule states that in 2010, they paid $10,580 to get in. But the actual, so this is rule, line of best fit, this is actual in the table, just in case they want you to compare, because comparisons seem to be a big thing they like you to be able to do. So rule is line of best fit, actual is table. Again, all of those are EOC questions. All right. These came from the actual from the state packet. A line y equals mx plus b passes through the point 16 and is parallel. So stop reading. As soon as you see the word parallel, what did you think in your head? Or what should we think in our head? Same. Good. Lines. Good. Parallel lines. Same slope. So again, as soon as you see perpendicular, you want to get your brain to say opposite and reciprocal. Opposite and reciprocal, not just one of them, because if you do just one, it's not right. And then as soon as you read the word parallel, they're lines that never touch, but you want to think same slope. And all the never touch, the 90 degrees, and all of that is very accurate. But for our class, our EOC, our test right now, this moment, when you see the word parallel, what they're testing for is the word same, referring to the slope. Because hopefully they assume you've learned that the word parallel means two lines that never touched way before now. So if I'm looking at this equation and I'm going to answer what is the line, what is the value of B that's parallel to that line, that 6 does not matter. All I care about is slope. The 6 does not matter. So that 4 is what I need. So I'm going to plug that back into y equals mx plus b. So y equals mx plus b. Because I have an x, I have a y, and I have an m. We know the slope is going to be 4 because it is parallel, which is the same. We're going to multiply that by 1 because we know that's our x value. We're going to solve for b, and our y value is going to be 6. So what's our new b value? Did I jump too fast? We want to solve for b. What's b going to be equal to? Good. Minus 4, minus 4. Because we want to get that to the other side to cross our great divide. We want these to go away. So b is equal to 2. And in this question, all the question asks is what is the value of b? And the line parallel to the previous. So we just answered it. The answer is 2. So this is the answer to our question. The line that is parallel that we just wrote would be y equals 4x plus 2. And the slopes are the same. The only thing that changes is our y-intercept. We used our point to plug in. All right. The total cost in dollars of a membership in a fitness center is given by the function Cm equals 20m plus 40, where m is the number of months a person is a member in dollars. Oh, sorry, member, period. In dollars, comma. How much is the cost of membership for 1 year? So the total cost in dollars of membership in a fitness center is given by the function, where m is the number of months a person is a member. Now, that means we're looking at this function. So let's think about all the things we have here. So y equals 20x plus 40. What is my slope? What is my rate of change in this equation? Oh, so close. There's only one problem with that answer. Otherwise, it's perfect. Slope is what letter? When we do our y equals mx plus b. Yeah, it's the 20. So m, just the 20. X is its input. Remember we talked about x is input, so he has a job. He can't be slope and input. Y is our output. Slope is 20. What's my y-intercept? Come on, guys, you got this. What's the y-intercept in that equation? If 20 is the slope, y is output, and x is input, what's the slope? What is the y-intercept? Yep, 40 is y-intercept. Good. And that could be your starting value, your initial value. Starting amount is probably a better word. Starting amount, initial value. So that means in this case, if we're talking about joining a fitness center, like I told you in our last class, like I love thinking about like butt sitting fee because it just kind of makes me giggle. As soon as you put your butt in a cab, you pay an amount of money. As soon as you walk in and order a pizza, you're going to have an amount of money. And then you're going to pay per topping, or you're going to pay per mile or per distance for a cab. In this case, that M, which is here, is per month. So our input, the thing we can control, is how long we're a member at the gym. So that X, the input, is how long. What we don't control, but is controlled by how long we stay a member in the gym, is our output. So that's our cost overall. Notice this is money, and the output is going to be money. The only thing that's not money is X, and that's that time. Right? So $40 to walk in and fill out our paperwork, $20 for every month we're in there, and then we know how much it costs. So if we're a member for 1 month, how much is it going to cost? I'm sorry, 1 year. I put months. I'm sorry. Oh, no, I see what they did. It is month. So 1 year. Oh, let's back up. I got more questions. They got me. Oh. So, year. This is months. So I have to do something with this. My units of measure are different, right? If this was multiple choice, they would have definitely given you $60 as a choice. Do you see where $60 would have come from? If you plugged in a 1 for your time, 20 times 1 is 20, plus 40 would give me 60. The problem is that this X is in months. How many months are in 1 year? Yeah, so we know this is going to be 12 months. So we're going to use our function, but we're going to plug in a 12. That's why this is EOC like. When I was typing, I thought, man, this is really easy. That's because I wasn't even paying attention. So what is the cost of our membership after a year? Grab your calculators, my friends. What is the cost after 1 year? Awesome. Oh, so close, actually. So close. Don't forget to put plus 40. Yeah, 280. Perfect. All right. So when they signed up, have you guys ever joined a gym before with anybody? Like been sitting there when your parents joined or anything like that? So there's usually a fee just to fill out the paperwork and join, like a joining fee. The joining fee would be that $40. That doesn't even mean you showed up. That doesn't mean you stayed. That just means you just told them you want a membership. And then the $20 per month is after that. So the $240 would be if they waived your joining fee. Sometimes you'll see signs that say that. We'll waive your enrollment fee. So that would be the $240. But $280, because you got to make sure to add that $40 enrollment fee in there, is where the $280 came from. Do we have questions about where those numbers are? Do you see where it could trip you, but also understand where they came from at this point? Or anything I can straighten out for you? Star it. That one and the one above it are EOC questions the state put out. Like the state said, these are questions we need to be able to do. They were calculator inactive as well. So all those numbers you need to be able to do on a scratch sheet of paper, like 20 times 12. As far as 20 times 12 on a piece of paper, if you do 12 times 20, obviously you can do 0 and get 2 zeros, and then 2 times 2 is 4, 2 times 1, and so then you have your 240. If you want to do it a little faster in your head, know that 0, we can ignore it for a second. 12 times 2 is 24, and then we have a 0, so we add a 0 on the end. That is not mathematically sound, but it's kind of a quick math hack. So if I was to say, what is 15 times 20? Ignore your 0. What's 2 times 15? Yep. And then we know there's a 0, so we add a 0. So it'd be 300. And that 0 is just multiplying that by 10. So we're taking the 10 away. We're using the 2, and then we're tacking the 10 on at the end by adding that 0 behind it. So if you wanted to do 18 times 30. Oh, that's ugly one. Let's not do that one yet. Oh, no, we can do it. 18 times 30. 3 times 18. 18 is not super nice, but 15 hopefully is a little easier, right? 15 plus 15 is 30, plus 15 is 45. And then we have 3 more than 15, because that's our 18. 3 times 3 is 9. So 45 plus 9 would give me 54. And then we're going to add a 0 to the back. Hopefully that made some sense to you. But you have to be able to do these multiplication on the side as well. And they're not necessarily the ones that you know straight off your like top of your head. So that's just sort of in case you forgot how to multiply without a calculator. Bigger numbers. You will be responsible for that as far as on the EOC. All right, 4 minutes. Sorry. And these last two are fun because I used y'all's names. So Eli, Ryder, and Derek went to Cold Stone to get ice cream after school on Tuesday. The function f of x equals 125x plus 475 models the cost of a scoop of ice cream with additional toppings, where x is the number of toppings. What is the cost of 1 scoop of ice cream? If that's the function, what is the cost of 1 scoop of ice cream? So our function is 125x plus 475. What's the cost of 1 scoop of ice cream? Yes, good. 475 is 1 scoop of ice cream. Because that's our starting cost. Like as soon as you order ice cream, you got that. Then how much does each additional topping cost from that function? How do you know? Yeah, $1.25 per topping. So again, if you see it, this is money, which is going to give us our cost for our ice cream. And X in this case is going to be the number of toppings. So how much does each cost? That's that 125 because it's in front of the X, because it is that slope. Good. So if Eli bought ice cream with 2 toppings, how much is his ice cream going to cost? Good. $7.25. Excellent. And you just plugged in the 2 in the place of X. So Ryder got ice cream with 1 topping. How much is it going to cost? Talk to me. Some of you guys who haven't been talking to me, you got to talk to me. Hey, Derek, welcome to class. $6. Good. Because it's $4.75 plus 125 times 1, which is just 125. So let's get you $6. Perfect. And if Derek got ice cream and it had 5 toppings, how much is that going to cost? Good job. Yep, $11. Only at Cold Stone would you have $11 ice cream. But yes, $11. Perfect, perfect. It is 3:44, and I don't want to overkeep you. The last one was good, though. Maddie and Mackenzie, you guys went to a fair. We'll talk about it next time if you want to. Otherwise, though, guys, I really did intend on giving you a little bit of a break today. So I appreciate you guys showing up, and I hope you have a fantastic rest of your day.